All right, so this is the second lesson for the A set of notes for Chapter 8, Solving Linear Equations. In this lesson, we are going to look at solving one-step equations, so having a variable that has one thing happening to it, so it's being times, or it's being divided, or added, or subtracted. Just one of those things is happening to it. So before we get into looking at equations, I want to just do a little bit of review with you. And so when we start looking at one-step equations, basically it's like a fill-in-the-blank type situation, okay? And the blank is being replaced with a variable later on in equations. So just as a review, I want you either using mental math, you can use calculators, you can use working backwards, whatever strategies you've learned to figure out what your blanks are. We're going to go over these at the start of class tomorrow, just kind of as a review. So I just kind of want this process in your mind before we start our lesson. Okay? So the first thing we can do when we're trying to solve an equation is we can solve by inspection. And what inspection means is things like using guess and check, using times tables, using your fingers, different things like that to help you figure out what's going on. Or the second thing we can do is we can use the inverse operations. And so inverse is another word for opposite. Okay, so we can use opposite operations. So just as a reminder, okay, so if we said positive, the opposite of, or adding, sorry, the opposite of adding would be subtracting. If we said subtracting, the opposite would be adding. If we said multiplying, the opposite would be dividing. And then if we said dividing, the opposite would be multiplying. Okay? So just kind of a reminder of what opposites are. So what we're going to do is I'm going to show you how to use the opposites to solve. And we're going to use inspection as a way to double check our answers. So there's a lot of examples here. I'm going to do a couple of them, and then you're going to do the rest. So in the first one, it seems really simple. We're starting really basic just to remember kind of what we've done in the past. So I want you to think of your equation as two separate sides that need to stay balanced, the left and the right. So whatever you do on one side of the equation, you need to do the same on the opposite side with the equal sign. So sometimes drawing the line down the middle helps you keep yourself organized. So our variable is m. So that's the thing we don't know. That's what we need to figure out. So m, so something plus 3 equals 10. We could probably figure that out in our head, but we're going to use this working backwards way. So instead of m plus 3 equals 10, we're going to do the opposite. So instead of plusing 3, we're going to minus 3. And if we minus 3 on the left side, we have to also minus 3 on the right. And so then plus 3 minus 3, these are opposite integers, and they equal to 0. So they cancel each other out. So now we're left with m plus 0. So that's just m equals, and so then we go 10 take away 3, 7. M equals 7. And if we double checked, 7 plus 3 equals 10, and it does. So we get 10 on both sides, so we did it right. Okay, if we jump down to the second one, j minus 6 equals 5. So j is the variable that we need to figure out. So j, so something take away 6 equals 5. We're going to do the opposite. So instead of take away 6, we're going to add 6. And whatever we do on one side of the equation, we're going to do the same on the other. I said 6, and then I wrote 5. There we go. So negative 6 and positive 6, opposite integers, cancel each other out. So then j equals 5 plus 6, j equals 11. To double check, 11 take away 6 should equal 5, and it does. So it cancels out, it checks out. Okay, so those are some adding and subtracting examples. If we look at the next one, 3 plus s equals 7. And so now the variable is switched the position, which is fine. This is still what we need to figure out. So 3 plus something equals 7. Excuse me, I'm sure you could do that mental math. We're going to work backwards. So this is a positive 3. If there's no sign written there, it's a positive. So we need to get rid of it by adding, by putting in the opposite, which is a minus 3. And so we're going to minus 3 on both sides. So plus 3 and minus 3 equals 0. And so we get s equals 7 take away 3, so S equals 4. And if we're going to double check, 3 plus 4 equals 7, and it works. Okay? On the next one, going down, oops, I don't know, where's my extend a page? There we go. I just want a bit more space. Okay, 12 divided by 8 equals 2. So now this one working backwards is a little bit trickier, but we can use our inspection. So we need to think, okay, 12 divided by what equals 2? So we could use the times table, we could use guess and check, we could use working for the opposite, right? Because we know 2 times h, or 2 times whatever h is, has to give us 12. So we could think 2 times what equals 12? Well, 2 times, holy man, mouth, hand not working, here we go. 2 times 6 equals 12. So that means 12 divided by 6 has to give us 2. So h is 6. So that's how we would use an inspection method, okay? Thinking, oh, well, 12 divided by h, I don't really know how to rearrange that, but I can think, okay, well, 2 times what equals 12? So using some mental math strategies, okay? When we look at the next one, 15 take away y equals 8. Same kind of idea, okay? So we need to kind of use some strategies. 15, how much do I need to take away from 15 to make 8? So let's start at 8 and count backwards. 8 plus what equals 15? Well, we start at 8 and we need to add 7. So that means y equals 7. And if we double checked, 15 take away 7 equals 8. And it does. Okay, and notice I'm still keeping my equal signs lined up as best as I can, even though I'm jumping around a little bit. Okay, I'm going to show you 2 more examples, and then you're going to try the rest on your own. I'm going to jump over a little bit. So this one is r divided by 2 equals 7. You might also see it this way, r divided by 2 equals 7. These mean the same thing. Okay, and so if we're dividing by 2, to cancel out the divide by 2, we need to do the opposite. So we are going to times by 2. And whatever we do on one side, we're going to do the other. And so 2 timesing by 2 and dividing by 2 cancel each other out. So we're left with just r. And 7 times 2, so r equals 14. If we look at it up here, if we times by 2, these 2's would cancel out that way. One on top, one on the bottom cancels out. Okay. To double check, 14 divided by 2 should equal 7, and it does. So it works out. The last example I'm going to show you is this one. And so we have 3x equals negative 12. So we have a coefficient and we have a variable side by side. I hope that you remember when you have 2 things side by side like that, but they need to be multiplied together. So this is like saying 3 times x equals negative 12. So to get the variable by itself, we need to do the opposite of timesing by 3, which is divide by 3. So we're going to divide both sides by 3. We'll get left with x. 1x equals negative divided by a positive. So now we're thinking of our sign rules as well. Opposites give us a negative answer. 12 divided by 3 gives us a negative 4. If we're going to double check, 3 times negative 4 should give us negative 12. Opposite signs being multiplied is going to give us a negative. 3 times 4 gives us 12. So it works. Okay, so those are the only ones I'm going to do for you. The rest you must do by yourself. I know, I'm horrible, I'm mean. Say what you want. Okay, so to help us remember our sign rules, so maybe you want to watch this before you go back and finish those other questions. We have our little cheat sheet. So if you remember the tic-tac-toe, the positives go down the one side, and then the rest are negative. Okay, and so let's say you had a positive times a negative. So positive times a negative gives us a negative. Okay, so opposite signs give us negative answers. Same signs gives us positive answers. So you are going to fill in the rest of this for me. so we can check it tomorrow. This should be review from grade 8 for you. And using inverse operations, again, we said the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplication is division. Multiplication. Okay, those are our opposites. So, again, I'm going to show you how to do a couple of these, and then you're going to do the rest on your own. So x plus 5 equals 12. I'm going to do the opposite to isolate the x. Instead of plus 5, we're going to minus 5, so x equals 7. Next one, y minus 8 equals 2. We have a minus 8. We need to do the opposite, so we're going to plus 8 on both sides. Y equals 10. 4m equals 8, so 4 times m. We're going to do the opposite of times, which is divide. So we're going to divide both sides by 4. M equals 2. Third one, r divided by 2 equals 6. So the opposite of divide by 2 is times by 2. So r equals 12. Okay, and these next ones you're going to try on your own. I know I'm giving you a lot to try on your own. I will give you time in class to work on them, I promise. But you should have tried some of them by yourself before coming to class, okay? So sometimes you'll be asked to verify if a solution is correct. Verify is a fancy word for checking your answer. Okay? On a couple of the examples on the first page, we did this, we checked them. I'm going to show you how we could check. So this question says verify if x equals 4 for the equation. So basically, is that the right answer? So what we're going to do is every time we see an x, we replace it with the possible answer, so 4. So instead of 20 minus x equals 16, 20 minus 4 equals 16. And then I actually solve it. I go 20, take away 4, 19, 18, 17, 16. Yeah, 16 equals 16. So yes, x equals 4 for this equation. We look at the second one. 12 divided by x equals 2. So 12 divided by 4 equals 2. 12 divided by 4 equals 3. So 3 equals 2. So no, this doesn't work. No, x is not 4. And sometimes the way we show that is an equal sign with a line through it. So x does not equal 4. That's not the correct answer. When we look at C, 7x equals 28. So that's like saying 7 times x equals 28. So 7 times 4 is equal to 28. 7 times 4, 28 equals 28. So for this one, yes, x equals 4. That's correct. Okay. And on the last one, x minus 4 equals 1. So I'm going to replace the x with a 4. 4 minus 4 equals 1. Well, 4 minus 4 equals 0. 0 equals 1. That doesn't make sense. So that's not the right answer. So no, x does not equal 4 for that equation. Okay, so you're going to get some class time to work on this. And there are 2 assignments printed for this lesson. So you are going to have 2 class periods to work through those assignments. And then you are going to have a quiz before lesson 3. Okay?